Hi there, this is Matt Heffernan. Welcome back to my channel. Today we've got another episode of Slithy Vlogs, episode number 28. And of course, as usual, it'll be a informal sort of chat about things I have going on. And this time we're going back to my game Word Slide, which I introduced a few episodes ago, back in January. And of course, it is a take on what is currently a very popular game online, but unfortunately, it is no longer just one guy that put it out there and is letting everybody use it for free. It has been bought by the New York Times and will likely end up behind a paywall at some point, like their crossword puzzles. And I think that we don't really need to submit ourselves to giant corporate media to enjoy a game like this. It's a simple enough game that you can play it on an extremely simple computer like a VIC-20. And what I'm going to show you now is how I took this game that I previously had made for the Commodore 64 and the Commander X16, all along with the intention of making it work for the VIC-20. And now I've got that working, and we'll see how we did that. So first, a bit of info on the VIC-20. It is not just retro, it's extra retro. It came out back in 1981, but it didn't originate actually in the North American market, even though Commodore is an American, or was an American company. That Jack Tramiel, the leader of Commodore at that time, was very happy with the success that they had with the Commodore PET at that time, but that was more of a business-oriented computer. There was no color graphics. It really wasn't a gaming platform. And in Japan, there were these low-cost microcomputers with color graphics that kids were playing games on at home, and he wanted to get in on that action. So a lot of the other folks at Commodore weren't necessarily bought into that. They really liked the way that the PET was going and the new things they were doing with it, including Chuck Peddle, who was one of the main architects of the system. But he said that he wanted to have, Jack Tramiel that is, wanted to have something to compete against these low-cost Japanese micros that he was afraid were going to come into the North American market and eat their lunch. So he actually introduced the VIC-20 as the VIC-1001 and put that out back in 1980 in Japan. And then, a few months later, eventually they released it here. And they were able to get that price down to $299, which in the American market was extremely cheap. Remember, we didn't have the uh, these really cheap micros like you had, say, in the UK with Sinclair's, ZX80 and 81 that were at that price point and even lower. So this was really something. And on top of all that, it had color graphics. And really, compared to, say, the Atari 2600, it was much more capable and maybe not as capable as Atari's 8-bit computers like the 400 and 800, but it was still a lot less expensive than those. And that really set it apart. And without having the confusion of having like three different things like Atari had, Commodore was able, at least briefly, to go all in on the VIC-20 for the home market, which of course is mainly focused on gaming at that point. And everything was going well, and well enough that, of course, as you know, the next year they put out the Commodore 64. And because of that, they all of a sudden had a whole lot of these VIC-20s that they wanted to move out. And so they really cut that price down. So pretty much selling them, I can't imagine, much more over cost, maybe even below cost, because quite often you could get them retail for under $100. And it was, an incredible value at that point. And so because of that, that sort of actually kickstarted sales. The Commodore 64 took a little while to get rolling in the sales department. And ultimately, they became the first the computer model to sell 1 million units, which was quite amazing. Apple hadn't managed to sell 1 million Apple IIs at that point, but VIC-20 did, and ultimately they kept making VIC-20s, or at least supporting them, up through 1985. By then the Commodore was about to put out the Amiga, and so yeah, it really spanned the whole early 80s for them, and they had a lot of units out there, and a lot of games were made for it, and it was, it wasn't going to blow anybody away. It wasn't going to compete with, say, the stuff that would come out in the later 80s, like the Nintendo Entertainment System. And it certainly couldn't really compete with the Commodore 64 once its prices started going down to that $299 price point and even lower eventually. It was still a very popular machine, even though it's mostly been forgotten. You're not going to have the, like the mini Commodore 64s that came out. You're not going to have that same wave of nostalgia for the VIC-20. But if you're watching my channel, chances are you probably remember, or at least have become familiar with it from its being featured in a lot of retro content online. So let's take a look at what we have to do to make the VIC-20 do what we did with the Commodore 64. Well, of course, like before with the Commodore 64 and the Commander X16, you had the common thing of the special character set along with character controls, and it's not quite ASCII, which also combines different control codes with character codes. It also has all sorts of graphics defined in it, and so named after the Commodore Petsky. And so here's what it looks like for the Commodore 64. The 8x8 graphics for each character and all these different control codes and the 16 different colors. Well, the VIC-20 didn't have 16 colors. It only had 8 colors in its normal mode. And so the graphics, of course, also look a bit different because the pixels aren't perfectly square on the VIC-20. They're actually twice as long as they are high. And so the character set ends up looking like this for Petsky. And you'll notice some of those control codes are not in there either. Mainly those additional color codes are not available. You only have those 8 colors. And of course, I knew that going in, and that's why I didn't choose any colors for word slide that aren't supported by Petsky. So you have black, white, green, and yellow, and that's all you need for the game itself. And you'll also notice there's a bit of differences between the way some of these characters look, not just in terms of being slightly looking different. Like obviously the letters look different, but even the graphical characters are different. Even though it's still 8x8, you'll see that some of these box making graphics are just single pixel lines instead of double pixel lines. Well, Commodore eventually figured out that, since a lot of folks are just putting these on TVs or even putting them on composite monitors, that these doubled up graphics actually look a lot better once you get that 40 column display going on a composite monitor. So you have a not quite incompatibility, but you actually have more different characters on Petsky than for the VIC-20 than you do on the Commodore 64, because Commodore 64 ends up actually doubling some of these because there's no difference when you make double lines versus single lines of pixels. So anyway, that's one way that we're able to do this fairly easily. And of course, the other big thing, like we talked about in my previous video on Word Slide, is the use of the Commodore kernel and the entire Commodore 8-bit line, and including these newer retro machines like the Commander X16 and the Mega 65 are all using the same API for that old Commodore kernel. So you have the same sorts of routines at the same addresses, and you call them and they will have the same behavior. Now, of course, the kernel is different from machine to machine, but you have a sort of a baseline lowest common denominator of functionality for that kernel. So stuff that works on the PET will work on the Commodore 128 and the Mega 65 and all of those. But here we're talking about this specific game, and you got to have color. And so some things aren't necessarily going to work out. And the way that I handled the last game, of course, I had it working for the Commodore 64 and the Commander X16. And by extension, if it works on the Commodore 64, it also works on the Commodore 128. Now, it wasn't working in the VIC-20 yet because there's enough differences in there. I can't just depend on the kernel to do it. I have to implement some things in a special way to make them work on the VIC-20, because it's not like the Commodore 64 is not backwards compatible with the VIC-20, so I can't just make a VIC-20 program and run it on all these other machines. I have to have unique code for each of them. And so really, with enough tweaking, I can make this work for any color machine that uses PETSCII and some variant of the CBM kernel, but unfortunately not the PET, at least not the way it is now. Some folks have considered different ways of making this work on the PET without having any sort of color graphics or even grayscale. It's all just, pure black or white binary. And it's I'm not convinced of any one good approach for doing this on the PET. We may be able to get fancy somehow with the 80 column mode. There might be a way of doing it, but the way it sits now, it doesn't look like it's going to work very well with the PET, and I don't have any intention of trying. But at this point now, I've got it working on the VIC-20, and soon to come will be these other machines. I think a lot of the work that I've done, that I'm going to go into a bit here for the VIC-20, by shrinking the code down to a manageable size, it's going to be able to work on these other machines that are that came out after the Commodore 64, but are less capable, like the Commodore 16 and the Commodore Plus 4. And those two machines are pretty much compatible with each other. And so I just have to really target the lowest common denominator between those, and then it will run on both of them just fine. And of course, also the Mega 65, which is compatible with the Commodore 65, which never came out, but I could definitely make something that will work on that, and that should require even less tweaking. It'll be pretty close to the Commodore 64 version, but I may have to do things a bit differently, kind of like how I had to do certain things that I couldn't do with the kernel, and did that using the special graphics of the Commander X16. I'm probably going to have to do something similar like that for the Mega 65 to get over some of those incompatibilities. But meanwhile, coming back to the VIC-20, even though it's extra retro, of course, comes along with that are the extra limitations. And the big one, of course, is the RAM. The baseline VIC-20 only has 5 kilobytes of RAM, and one of those kilobytes is already being used for the screen and color RAMs. So you can't just use those for anything, because you're right to that part of RAM. It's going to show up on your display, and you need to have that RAM available to you so that you can put stuff on the display. Yeah, so that's not going to work too well. So what we had to do is get this code down to a size that can fit not just in RAM, but maybe also make use of the ROM cartridge, because the VIC-20, rather than folks using tape or disc for a lot of games, the cartridge is really big, because the ROM cartridge actually lets you take up a full 8 kilobyte segment on there, and that's where it would run generally at the 8,000 hex range. And then you could actually have bigger ROMs than that. There were additional segments at 2,000, 4,000, and 6,000 hex. And so if you had a 16K cartridge, which did happen. Those did exist, although they were going to be a little expensive because ROM chips weren't cheap back then. You could have a 16K ROM that has sort of the executable, the initial executable part at the 8000 segment, and then it would have the 2000 segment also populated. And so what I can do is emulate a 16K ROM, but keep the program in 8000 because that fits well within 8K. It's much smaller than that. And then I can have the word table, that database fit in the 8K, but unfortunately the database before was quite a bit bigger than 8K because it has like 2,700 words at this point, and with 5 letters each, that's way more than 8 kilobytes. So I had to get a little fancier with it. So I had to come up with a way of doing fast compression and decompression of words in this word list. And one thing I had thought of before, and other folks had mentioned too, that well, you really only need 2 bytes for each word. And so how do we do that? Well, so to get it down from 5 letters to just 2 bytes, it means that we're going to have to really lean on that lookup table. And so the lookup table already tells us enough information saying, oh, starting at this address, we have words that start with these 2 letters. So you really don't need to store those 2 letters for each of those words. With more code, you can just kind of introspect that lookup table and say, okay, you're within this range in the word list, then we know it's going to be starting with these 2 letters. And then the same way is when I go look it up, I'm looking up a word in the word list to see if when I make a guess and see if it exists, I'm already indexing into that lookup table with those first 2 letters, and then I only have to search for the rest of the other 3 letters, which I again can condense down into those 2 bytes. And so it's going to kind of look like this. So the lookup table starts at the beginning of that second segment of the ROM at hex 2000. And of course, lookup table is alphabetical order, going by the first letter first and then the second letter. So, A, B, A, C, and so on until you get all the way down to the ZZ. If you ever had ZZ letters in your word list, there's a spot in the lookup table for it. And so then after that ZZ address in the lookup table, you start to see the words themselves, and those words are condensed into, again, 16-bit words. So these 2 bytes that have everything you need. And here we can see, you can't really tell without looking back in the lookup table what the first 2 letters of any of these words are because they're omitted. So here we can see that where this address is 2566 hex, which is AC. So all of these are words that start with AC, and then we could take these words here and then decode them into the remaining 3 letters. So here we have aches, acids, acing, and then this last one. So what's this last one? 7C8E. Neither 7C or 8E, of course, are PETSCI codes because there's actually 3 PETSCI codes embedded in there. But the nice thing to know is that when we want to decode this, we already know, of course, the first 2 letters are going to be AC just by virtue of where it sits in the table. And then we can take that and say, oh, okay, so let's just put all those bits in a row, and we actually only need 5 bits for each letter because the first 3 bits, the upper 3 bits of any PETSCI letter code is going to be 010. Or hex 40. It just has to be ORed with some 5-bit unique value. which is going to range from 1 for A, and then all the way up to 26 for Z. And so here we can see by only requiring 5 bits per letter, we have 16 bits, of course, across 2 bytes. So we even have a spare bit in here that we don't even need to use in those 2 bytes. So here we take 7C, 8E and split that up. So those first upper 5 bits of that first byte, we've got the 7 and then the upper bit of the C. And so there we have a binary value, a 1111, which is 15. So that's the 15th letter. And then the same thing here. So here in the pink, the lower 3 bits of the C, the upper 2 bits of the 8 form another. That is the 16 plus 2, 18th letter. Oh my goodness. Yeah, so the 18th letter, and then here at the end we have the E, and in fact it ends up being whatever hex E is, which is 14. So the 14th letter. So we have the 15th, the 18th, and the 14th letter. And what's that give us? It gives us acorn. So there we go. That's how we're able to take just those 2 bytes and have a full 5-letter word. And before you ask, no, I'm not doing a BBC Micro version just yet. But you know what? Maybe in the future. So we'll see. It's going to have to be quite a bit different than this Commodore version. So let's take a look now at how we have this all put together. Now, we've seen before how the source of the word list is, which is just an alphabetical list of words fully in the 5 letters for each word. So not compressed yet. And before, basically, we were just stripping out the new line characters, those little carriage returns and line, or line feeds or whatever, and pulling those out and then just sticking the lookup table before those. But of course now we've got to come just after that lookup table, do the 2 bytes per word. So now word table.c will do that. So once we read a letter, then we're doing all of this business right here. When we're writing it out, we're taking indexes 2, 3, and 4 and just squeezing them together, chopping off those upper 3 bits and stringing them together into those 2 bytes like we saw in that slide, and then writing that out for each word. And of course, still keeping track with the lookup table. And then the thing here is we can see that our lookup table count, we're only going up by 2 bytes now for each word that we add to the list instead of 5. So yeah, obviously we're going to have a much smaller file here for the word list. And then once we get here into the code, we're still having that same start code, and you can see some of the things we already had in there, like we're setting up a black background. I've decided to change it to a blue border and not just be a black border like I had originally planned. I think it actually looks nicer to have that blue border, just like how we have that sort of purplish border for the Commodore 64. Of course, you don't need the border for the Commander X16. We're talking about an RGB thing, but it is a bit different here because this start will not be at the same address because we're targeting a cartridge here. So if we are VIC-20, of course we can't, if we're putting all this code on a cartridge, we can't have inline variables either. So we have to sort of do things a bit differently. And first of all, what we have to do is at the very top, we have this segment called startup, which will I have a custom configuration. Of course, all of this is in the repo. Go to the repo that's linked in the description of this video, and you'll be able to get all this code and get the configuration files for CC65 to be able to do this yourself. And maybe make your own VIC-20 cartridge application. Why not? So once we're at A000, we want to have a vector for where to start the code. So we give it that reset label. And then we have to have some magic incantations here after that lets the VIC-20 kernel know that, oh, hey, this is a cartridge here at in this memory segment. So that's how it can tell when it actually starts to read that. It knows it's not just garbage that it's reading there, because that's what you would basically get if you didn't plug in a cartridge. But if you did plug in a cartridge, it would have this very specific pattern there, and we know that, oh, yep, there we go. We've got a cartridge, and it knows what to do with it at that point. So then here we get into the actual code, and we have to do a few things to basically, we're not going to have the VIC-20 booted already. When we power it on, we have that cartridge in there. It's not going to boot to BASIC. It's going to boot to this ROM. So, of course, using the kernel, using some of the basic code that's in the VIC-20 ROM, none of that is, of course, mandatory. You can totally ignore the built-in ROM and just go off your own ROM. But here, since I'm going to use the kernel, I have to then initialize the kernel myself. So I put that initialization code up in here and enable the interrupts so that we'll be able to get the keyboard to be read. And so that's all special stuff I have to do just for the VIC-20. And then you can see here in the else, I am starting the other guys for the Commodore 64 and the Commander X16 at hex 80D like we always do. But then we get to that end if, and we have those different segments are all set up the same way for those other machines. And then we have our jump. And this would be the first thing that we'd execute for the Commodore 64, the Commander X16, but for the VIC-20, we would execute it after this little initialization phase. And then we can include all the stuff, and then all of this stuff, all this data, this is constant data, so we can just keep that on the ROM. We're all set there, including that initial screen text. Again, with all these PETSCII codes, and all these PETSCII codes will work the same on all three platforms. And then once we get to here, we have some things we're actually not going to use in the VIC-20, like the file name. We're not going to be loading the word list from a file, but that's okay. We got a little bit of stuff to spare. And then all this other stuff. And then we get to these variables, and here we have to be conditional again. We can't have the variables in line for the VIC-20 because we're still here in a ROM. And so in theory, I don't really need to have this all here. I could just do everything like this, but I may not be able to have it at the same spot, but I could find a place in the RAM of the VIC-20 where I could keep these variables that are going to work for all the platforms. But for now, I'm just hard coding all of these variables, starting with answer at the beginning of regular RAM in the VIC-20, which is 1200 hex. And then just instead of having these res statements that reserves a bunch of bytes, I just do a plus whatever the size of the previous variable is. So the answer is 5 characters. So the next one is going to be an answer plus 5, and so on. And then just a few other things that need to be different, like what do we have access to on the 0 page? And of course, that's different for all these machines. I need to have now 2 different pointers on the 0 page because all this compression and decompression requires more indirect addressing. So I now maintain a pair of pointers in there. and just taking whatever's not going to interfere. And for the VIC-20, there is a use by the kernel for every single byte in the 0 page. So I used two that I knew would never be used in conjunction with this cartridge, and those would be ones that are strictly for the tape interface. So I just go ahead and take those over, and then we're good. And then just a few other things, like I showed you the background. And then the one thing, and this is something that if you have a better idea of how to do this, please put it down in the comments, because it's the randomization is not exactly obvious how to really do this best on the VIC-20. And I have seen that stuff coming up, the same words coming up frequently. So the randomization is not great. I'm depending on the pseudo random number generator in the kernel that BASIC uses. And so here I am still trying to get the real-time value, but again, that appears to just reset for the VIC-20 and power up. So this isn't really terribly random. So it seems like most of the time I am just seeding this with the same time, and but then still just going through, and each time I want to pick a word, I am calling that random function out of BASIC. And then, of course, other things I have to do, since I'm not loading the word table from a file, I have to use the lookup table to figure out where the end of that word list is in the ROM. And so I do a bit of calculation for that. So in some cases, the VIC-20 actually requires a bit more code to work. And then, yeah, here we have how we're actually getting the random word. And of course, we have this special entropy function in Commander X16. We have the SID, the noise generator, and the SID can be used for random number generation, but we don't have something like that for VIC-20, so I am calling rand right here. And I am taking the 4-byte mantissa value. It's a random floating point value. So I'm taking that mantissa and doing an I'm doing regular ORs instead of exclusive ORs. That's not as good. Oh, you know what? Maybe this will help it a bit, wouldn't it? So yeah, I meant to do exclusive ORs with that. That may help me out a bit more. I mean, it's always good to be able to talk through what I'm doing and to see the stupid mistakes I've made when I put it in a regular OR when I meant to do an exclusive OR, like of course I had done already with the other two. So yes, I'm doing an exclusive OR between taking the 2 pairs of bytes for that 4-byte mantissa and exclusive ORing them together now, and using that as the random number, and then indexing into the word table with that. So, but then after that, all this code here, this is all the same. I've got a lot more code now for doing that encoding and decoding and searching through the lookup table, but so far it seems to all work pretty well. And then the only other special code that I needed for the VIC-20 is down here. When I am changing the color of the letter here, I'm not doing it with the kernel. I am having to poke directly into color memory. So, of course, there's entirely different ways of doing that for the Commander X16, the Commodore 64, and now with the VIC-20. And, of course, the VIC-20 has, unlike the Commodore 64, where you have these 40 character rows, you only have 22 characters for the VIC-20, so you've got to multiply by 22 instead of 40, and then you have different addresses that you're poking to. And it's kind of weird that the location of the screen RAM and the color RAM changes depending on the memory configuration that you have for your VIC-20. So you actually have to get the starting page of the screen RAM from this register here, this variable that the kernel populates, and then do an AND of 3 and an OR of hex 94 to get the color RAM, because that could be in one of two places. So it's all kind of weird, the way that the VIC-20 works with that. But ultimately it works, and that's it. That's all you have to do that's special, and of course the rest of the code's all the same. And what we do need, though, is a bit of a different build process to get it. So we still have the same very simple monolithic builds for the Commander X16 and the Commodore 64. It's just using the standard configuration. But here for the VIC-20, I have a special config file that I have in the repo for the main segment of a ROM cartridge. And so I'm building that out. And what I'm able to do by virtue of using this configuration is that it's automatically taking the code from my assembly language file, and it has all the data in the machine code and all that, and then it's able to fill that in with zeros to get it out to a full 8K. And then for that word list that I generate here with that word table C program, and it gives me the output file words.bin. That words.bin, that file that we load into RAM for the other computers, it's that same format we want, but like the other cartridge, like the other segment of the cartridge, we need to have that also padded out for emulation purposes. And so we can just do that with a pair of DD statements. So we start by just creating a file that just has 8K of zeros in it with this DD statement. And then we go in and take that file and just overwrite the first part of that with words.bin and leave the rest of zeros by saying, no, we're not truncating that at that point. And then that's it. That's all we have to do to do that. I did create a configuration file for this 2 segment of the cartridge. And so in case you wanted to put code there, you could use that configuration. Or if you wanted to do a different way, instead of doing these DDs, if you wanted to have an assembly file that you could run through CA65 and generate the proper cartridge artifact for that, you could do that as well. It's really up to you. But I found this way to be just a lot simpler, more direct. So now, once we run this build script, we will see here the, of course, that words.bin, which is now down to 6,820 bytes. And we are able to then put that into cart 2 and fill that out with zeros for 8K. And that cart A, so that's where the code is from wordslide.asm, is now cart A. And of course, they're both entirely 8K with that zero padding at the end. So now to run these, I could take those images and generate actual physical ROMs to put into a 16K cartridge and plug it into a real machine, but I don't have any of that. So what I have to do is this incantation here. So I use XVIC, which is the VIC emulator that targets the VIC-20. And what you can do, unfortunately, it doesn't support any sort of file format where you can just say, all right, well, here's my cartridge, and here's all of those. Here's how I'm populating each of those up to 4 different ROM segments. Well, no, you have to say, all right, what are you going to have in the A segment? What are you going to have in the 2 segment? And so there you have to pass it those files. And of course, both of them have to start with the 2-byte header saying where they're going to go, which VIC uses just to make sure that, oh, hey, yeah, this is meant to go at 8,000 and this is meant to go at 2,000, because you put 8,000 and 2,000 respectively in the first 2 bytes of each of those files. And so that will all work. I know there are efforts underway to create a better standard for VIC-20, but unfortunately, like we saw before, the audience for VIC-20 is a lot smaller, so there's not as much new development happening for the VIC-20 and not enough people really striving to make a better tool chain for modern development targeting the VIC-20. But I'm doing my part. I'm at least going to put this this stuff out here open source, and you can take advantage of some of the stuff I did. But there we go. Here's the VIC-20 one. We're going to get this nice and big, or maybe not. The VIC-20 emulation doesn't like to get bigger. But there it is. Of course, it's a little fatter than the original Commodore 64 one. These nice fat pixels on there. But otherwise, it works the same. I like to start with laser as the first word, but it's not gonna work. So then if laser doesn't work at all, I like to use count as the second one. But then I can see I've got the O and the U in the right place, and the T and the C are in there, but in the wrong place. So it's probably touch, and it's touch. And so there we go. That is how it works. And I hope you found that interesting. And we'll go ahead and try this out for yourself. You can try it out on the VIC-20 emulation. Of course, linked also in the description will be the web-based version that runs on the Commander X16. If you want to try that version, that's the easiest one to try because you don't have to install an emulator. It can be all done on the web, and you can just try out the game, and it plays the same regardless of platform. It just, of course, looks a little different on the VIC-20. But if you have an actual VIC-20 and you can figure out a way to, once you build this, I'm going to be putting out a new beta release of this that includes the VIC-20 artifacts for these cartridge images. And if you can get those burned on actual ROM chips and put in a VIC-20 cartridge, or perhaps one of these newer fancy flash-based ones. I don't quite know how all that works with these multi-segmented ROMs, but I know some people have figured that out. So please do, if you were able to do that, let me know in the comments, or even better, post a video here on YouTube, and I'd love to see this up and running on a real VIC-20. All right. So if you like seeing this and want to find out more about the things I've got going on, go ahead and subscribe here on YouTube. Of course, that's always free, but you can always join as a member, or even better yet, come join our community here on Patreon. And just like the people you see here, you get a chance to see all the videos that I put out ahead of time, get to provide some feedback before it goes public, and just be part of this general community that is supporting content creation for these old machines, and supporting the creation of new games for these old machines, even for the VIC-20 that really needs to get some more love. All right. So I hope you enjoyed this. I hope that this was educational for you, and that you come back again really soon. All right. Thanks, and bye-bye.